In order to determine which values would make an algebraic inequality true, you would use the idea of substitution. For example, if you had the inequality x is less than or equal to 9, let's say that the x was a 20. You would substitute a 20 in the place of the x and read the statement to yourself. 20 is less than or equal to 9. No, it's not. So I would know that this is not a possible solution. If x is 0 and I substitute a 0, I would read 0 is less than or equal to 9. Yeah, it is, which means that x being 0 is one of the possible solutions of what x could be. If I substituted a 10, I would have 10 is less than or equal to 9. No, that's not true. So out of these three options, 0 would be the only possible solution, but there are infinite solutions. If your inequality has an operation in it, though, that would require some additional steps. Still take the different values for x that you are testing and substitute them into the original inequality. The only thing to do now would be to simplify a little bit, because on the left-hand side, I see two terms, but 20 minus 7 can be written simpler. It could be written as 13. And 0 minus 7 could be written as negative 7. And 10 minus 7 could be written as 3. Now, I'm going to see if these statements are true or false. The first one says 13 is less than or equal to 9. No, it's not. So I know that 20 is not one of the possible solutions for x. Negative 7 is less than or equal to 9. Why, yes, it is. So I know that 0 is one of the possible solutions. 3 is less than or equal to 9. Yes, it is. So I also know that 10 is one of the possible solutions. There's not just one number that is going to make an inequality true. There could be infinite numbers that make it true. But this shows how to take a solution and substitute it into an inequality to see if you get a true statement or not. And if you do, then yes, that would be a possible solution.